demonstrations here. Okay, great. So we have the table. I'm going to go ahead and clear that off. And now we can do the import of data to that table. To do this, we're going to use the absolute workhorse of a command. We are going to attach that role, and then we are going to add that IM role. Easy to forget that button, by the way. And so now we've attached the role Redshift. We're going to say we're done there, and we are going to jump right back in, as you might guess, and we are going to rerun our query now that we have attached that role. Here, promised, let's take a look at the AWS Redshift architecture. It really is an interesting architecture, and there are some surprises. Now, before we get too deep into the architecture itself, let's just review a couple of the overall principles of AWS Redshift. The AWS Redshift service found its life in 2012, and it was a massive success for Amazon. In fact, Redshift quickly became one of their fastest growing services. And this is directly a result of the fact that there's more data than ever that organizations want to store. Take our example of Carved Rock Fitness. Initially, they were interested in storing data on their various outdoor products, and they were interested in storing data on their customers, and they were interested in storing data on sales transactions. But then when they had a larger than ever online presence, when they started an online community, when they started branching out into health clubs, and when they even started having the Internet of Things devices all over factories and health clubs and warehouses, then they realized, my goodness, we want to do analytics against this data, and we need help with the storage of all of this data. And keep in mind that the data is often in many different forms. AWS Redshift, as so many of the services are at Amazon, it's fully managed. So we love that here at Carved Rock Fitness, because we're not going to have to deal with the administrative overhead, and it's substantial, that would be involved with maintaining a data warehouse ourselves on-prem. It can scale incredibly. As you're going to see, the AWS Redshift is a cluster of compute nodes inside of AWS, and we can scale it up to 128 cluster nodes. This gives petabytes of data the ability to be stored here and analyzed. And of course, along with all of the key services of AWS, this Redshift tightly integrates with many other services. When we are tossing data up to the cloud for AWS Redshift to store, we can toss that data into an S3 bucket, for example. And then S3 can very, very efficiently move that data into Redshift. And we know it's actually the other way around, right? Redshift will reach out to the S3 service, and it will pull that data in. Now, AWS Redshift is really, really celebrated for how high performance it can be. Now, while this is a very performant platform, just keep in mind that that's not automatic. We need to know what we're doing as far as best practices go to get the very best performance out of it. Remember that AWS Redshift is not, I repeat, it is not designed for online transaction processing. No, we would use something like AWS RDS for our transactions that we are having the database take care of. This is designed for the analytics, right? So we're going to be doing the analytics processing and the business intelligence type manipulation of the data that's in AWS Redshift. This is, as you know, a growing field, as we can glean very valuable business information by looking at all of this wonderful data. It's ANSI SQL compatible, so that's great news for those of us that cut our teeth on SQL as we were learning database technologies. And finally, instead of storing and processing and working in rows, as is typical in like an online transaction processing system, this is column oriented. We'll be talking a lot about that in this course, but it's very important to realize, yeah, everything's in terms of columns, not rows. Now, when we look at the AWS Redshift architecture, the first big surprise for many is that we are talking about something that is constrained to a single availability zone. So right away you might go, well, wait a minute here. What about high availability? With high availability designs, we like to leverage multiple availability zones. But in this case, we do not do that. And that is because we have a cluster, and the cluster needs to be guaranteed high bandwidth connectivity between all the nodes, so everything stays within an availability zone. And something else that's worth pointing out about this is the fact that, remember, this is for data analytics, so by its very nature, it's not going to really typically need the same level of availability that we would have with like a transaction processing system. Well, when it comes to the cluster itself, it is made up of an important compute node that's called the leader node. Take me to your leader, we could say in Redshift. The leader node is where we would make connections like with our ODBC connector, or maybe we're connecting in with a SQL connection, and we connect to the leader node, which then runs queries and does processing in parallel against multiple compute nodes. That's the big deal here when it comes to the robust performance that we can get. In fact, many like to refer to Redshift as an MPP style database. That stands for massively parallel processing, and that is a great thing in the world of data warehousing. We love that we can process these tasks in parallel. And notice from this architecture too that we can easily scale. So as we are getting more intense with the amount of information that we're storing in Redshift, and as we're getting more intense with the types of analytics that we want to do, we can scale the compute nodes out by adding more of them, or scale them in if we have to by reducing them, and we can also scale them up or down. So we can make larger compute nodes or smaller compute nodes. So lots of options there, and we'll be discussing this as part of our overall best practices. So the architecture and the selling points of Redshift, they are legitimately exciting, and it's important for us to review this information, obviously, before we move forward. Just like with any AWS service, we really want to practice with the deployment of the technology. And I find with sophisticated solutions like AWS Redshift, students often don't do this. And I know one of the concerns is probably price, but if we're very careful to use AWS Redshift for a short period of time and then shut things down or even terminate things, it's not going to be a huge expense. And take it from me, should you forget to shut things down and leave them running and then get a massive bill from AWS, they'll be great when you call them and explain the situation. Yeah, they're really, really great about credits. And in fact, I've had it happen more than once where they've taken that as an opportunity to look at all of the services that I've configured and tell me other things that clearly I was demonstrating for students and inadvertently left running. Now, as part of this deployment, the very first and very cool thing that we are going to do is we're going to generate, how about 40 gigs worth of data so that we have something to experiment with inside of AWS Redshift. How fun. So I can remember back in the day when I used to teach database technologies, and back in the day meaning 25 years ago, when it came to giving sample data to students, I would create something. Maybe a database about my album collection or a database about books that I had written. Lame-o. With the data creation capabilities that we have today, you're going to be really excited. Now, we are going to use an EC2 instance in order to generate this data. And something that we want to do as a prerequisite first, before we go in and generate the data together, is let's create a role so that the EC2 instance that's going to generate the data can reach out successfully to resources like AWS S3. So I'm going to create a new role here, and it's going to be for EC2, and I'm going to go to the permission step, and I'm going to go ahead and just lazily give this role administrative access, so administrator access for the role. The name of the role that I'm going to use, so the name key and then value pair will be, how about role underscore data gen? And then review this, give the role its official name, which will be role underscore data gen, and all that looks good. We're going to create the role. So there we go, one of our little prereqs there. Something else that we should do is let's go to the EC2 console, and you'll want to scroll down here and go ahead and generate a key pair that you are going to use for accessing the data gen EC2 instance. You can see that I've got one right here, KP underscore Redshift. So I'll go ahead and utilize that key pair to access this EC2 instance that we're about to spin up. Notice if you don't have a key pair that you want to use, just use the create key pair button and you'll be able to give this thing a name, and it downloads to your computer, and you need to really make sure you have access to that so that you can get to your EC2 instance. So now that I have those prerequisites in place, let's go up to the EC2 dashboard, and we're going to go to instances. There are no running instances, how very sad, and we're going to choose the launch instance button in order to create our data generator. Let's use the Amazon Linux 2 AMI as the operating system. And then, this is going to be fun, on the instance type, you want to choose something that is pretty robust. Let's go down to the M images, and I'm going to do like how about an M5X large, okay? So we're talking about 4 CPU cores and 16 gigs of RAM. We are choosing something like this because we want the data generation to go quickly. Remember, we're going to have this node generate 40 gigs of data to load into Redshift. So we want that process to go fast, and then we're terminating this thing, right? So we should actually save ourselves money by using a beefier machine. It'll be done a lot quicker with the data generation, and then we can delete the machine. So I'm going to go to instance details next, and I'll just put this in my default VPC in any available subnet. It's going to auto-assign the public IP. That's great. Here is a key step. We want to go and grab that role underscore data gen that we created and associate it with the EC2 instance there. Other than that, we're ready to go to the storage step, and we are going to add a nice 100 gig SSD. Why so much space? Well, remember, we're going to be generating that 40 gig of data. I'm going to go ahead and add a name tag, of course, and this system will be EC2 underscore data gen. And then our security group, we will create a new security group. I'll say SG underscore data gen. It allows SSH, of course. This is Linux after all, and I'm going to leave it open to the world. We're not going to be using this EC2 instance for long, that's for sure. And we're going to launch this thing, and I'm going to specify it's the KP underscore Redshift, and I'm going to acknowledge that I really do have access to that key pair information. And there we go. We can go ahead and just go back to the EC2 dashboard now, and we can see that our instance is running, and this very important system right here is going to be the system that we use to generate no less than 40 gigs of data that we can work with inside of Redshift. In the next video, we're going to go ahead and access this data generator and actually do the data generation, and I hope to see you there. In the previous video, we went ahead and created an EC2 instance that we were going to use to generate plenty of data for Redshift utilization. And let's go ahead and get that done now. So we're at this EC2 instance. I'm going to choose connect. And notice that I can just copy this string here for my SSH connection. So I'm going to copy that and then bring up the dark place, as we used to call it, inside of Windows, the command prompt. And here we're going to go ahead and just paste in that SSH string. Actually, you'll want to make sure you're in the directory where your key is, though. So let's go and do that. So I'm going to do a change directory into OneDrive, and then, yep, it's AWS_keys, and you can use tab autocomplete, believe it or not, in Windows to help get that done. All right, now we're going to paste in our SSH string, and we're going to say, yes, we want to continue to connect to this instance. And now we're going to go ahead and get the data generation handled. We're going to be calling upon the great work of the tpc.org. There's the TPCH benchmark. This is a great tool set for data set generation and for doing analysis of the performance, benchmark performance of database technologies. So those good folks up there give us great freeware tools that we can utilize. All right, so here's what I'm going to do. I'm going to be doing this from Git, surprise, surprise. So we're going to do a sudo yum, and we're going to install make git. And this is our first step. We're going to say, yes, we want to go ahead and complete this installation. Then we're going to go ahead and do the clone of the appropriate git. So I'm going to do git clone, and it's going to be https, and it is github.com/Greg Ron. If you have a chance, go check out his profile. Impressive individual, and I love his tagline. He was into big data before it was big, or something like that. It's great. And then tpch-hit. All right, excellent. So there is the GitHub clone that we're going to do. So we have those resources here on this system. The next thing we're going to do is install some compiling tools. So sudo yum install gcc. We'll get that done. We're going to say yes to that. And then we are going to set some variables and things. We're going to actually make some files here. And those are now located. If you do an ls, you can see you've created, thanks to Git, this tpch-kit directory. So we're going to change into that directory. And inside of that directory, there's a dbgen directory. So let's go into that directory as well. All right, now that we're in that correct place, we're going to say sudo make, and I'm going to do os equals Linux. So we're going to compile some tools there with the operating system set to Linux. All right, next up, I'm going to do a cd $home, and in our home directory, I'm going to go ahead and just make a directory, and this directory will be called just data, and that's where we can go ahead and dump the 40 gigs of data that we are going to be creating here. Something else that I want to do is I'm going to export a variable entry here for the DSS underscore path, and the DSS underscore path is going to equal $home and then / data. So here we're giving the path location where we want to be doing the creation of the data. All right, so let's see. I think we're ready to create the data, so I'm going to hit enter there, and we are going to go and get back into that directory. Let's do the cd tcp. Actually, where am I right now? All right, yeah, so we want to change directory to tpchkit, and we're going to dbgen. All right, and here we go with the data generation. We're going to do // and we're going to run dbgen space dash lowercase v dash uppercase T lowercase o dash s, and we are looking for 40 gig. When you hit enter, it's going to start generating all of this data for, notice, an orders table and a line item table. And again, 40 gig worth of data thanks to the TPCH population generator. So this is awesome, and I'm going to pause the video right here, however, because this does take a good 15 minutes. Lots of variables in how long it's going to take, like what machine you chose, but I think it's safe to plan for about 15 minutes. So I'm going to pause the video, and we'll be right back to verify the generation of our practice data. Well, I must admit, I think I left a little too long there. You can see that I lost my SSH connection. No problem. I'm going to up arrow on the keyboard and just get right back in. And let's see if this was a success. So if I do a list, we remember that we created that data directory. And if we take a look in there, look at that. There's our line item.table and our orders.table. Now, let's really verify that we've got a bunch of data records here. So I'm going to do a WC. We're going to count, and I'm going to do a -L, the orders table. Now, this is going to take a little bit of time to count the records. Oh, no, look at that. It was very, very fast. Okay, great. So there is 4 million records or 4 million lines in the orders table. That is so cool. Let's check out the line item option. So I'm going to do the WC and then line item, and we actually need the -L, don't we? So -L. And we have, wow, what is that number? 16 million entries in the line item table. This is great. We have generated a whole bunch of data here with this great free tool. Now, a best practice when you're working with data sets like this is you can go ahead and split these entries. So this is a really nice technique. Watch this. So for the orders table, where I had the roughly 4 million records, I can say split -D -L, and for that one we'll do, how about files that are 1 million in size? So you're going to give the size there -A for, and I'm going to specify the orders.tbl and then the orders.tbl and then dot, and it will append a numeric for each of the incrementing files. So let me hit enter, and it will go to work splitting those entries. Let me do an ls, and there we go. We've got our orders tables now that are split. Let's do the same thing for the line item. Here we had a lot of records, 16 million. So let me issue the split command again, and we'll go in and say, oh, how about, let's see, 16 million. So, boy, I'm terrible at math. We know that to be true. Let's do 4 million. for the split here. And we're going to, of course, doctor up this name right here. So this is going to be the line item, if I can type that correctly. There we go. And then this is line item right here. All right. And that looks good, and that has executed. Let's do an ls again. Yes, that worked beautifully. Now we can remove the originals. So we're going to do line item.tbl, and then I'm going to remove the orders.tbl. There we go. So now in that directory, we just have our split database, raw data that we can utilize in Redshift deployments when we are testing and, initially validating designs. So this is great. Well, in the next video, we're going to go ahead and we're going to copy these items up to an S3 bucket. And that's a perfect place for us to have this raw data so we can work with it in Redshift. In the next video, we'll also get rid of, goodbye, to this data generation machine that we no longer need. It's served its purpose well. As you might guess, copying the data from our EC2 instance to S3 is going to be simple. Let me start by creating a bucket for this. So I'm going to call the S3 API with the AWS command, and I am going to create a bucket. And that was a nice attempt at spelling bucket, wasn't it? So there's my create bucket, and I'm going to go ahead and create the bucket of a name A Sequera. That's pretty unique. And then to Redshift. All right. And then we are going to specify the region, of course. So I'm in US East 1. All right, let's get that bucket created. And by the way, you may want to be connected to your actual EC2 instance when you run this command. But since I'm very confident that that syntax is correct, I'm going to go ahead and copy that syntax so I don't have to type that again. And very good. Oh, look at that. That's great. So what happened there was I have the AWS CLI installed on this local system. That's hysterical. I'm not surprised. So it was actually able to run that for me. That's great. I had planned on being in the EC2 instance, of course. So let's get back into our EC2 instance. So I'll do the AWS S3 and then CP, or copy feature. And we are copying from the home data directory, as you recall, to the S3 location of, what did I call it? A Sequera to Redshift was the bucket that we created up there. And let's see, what else? Oh yeah, we would want to make sure we do this recursive. So there we go. The copy is in progress. And notice we have 2.4 gig. So I didn't think my data created all the way. So that's pretty funny. I didn't get my 40 gig of data. So I would want to rerun that process because it did not complete, but that's okay. I've got 2.4 gig of data, and that is certainly enough for us to experiment with. In fact, notice it just made that copy go a whole lot quicker. So now that I've got the data up in S3, I'm going to go ahead and terminate this instance. Boy, sometimes these EC2 instances, they don't get any love, do they? This thing has been a real workhorse for us. It has generated all this great data for us to work with. And now, unceremoniously, we just come up here, we go to instance state, and we terminate that instance. Think about the key pair that you created. So you're going to decide whether or not you're keeping that key pair. You will want to go into the identity and access management and clean up that role. And you'll also want to go in and clean up the security group that we created. So there's our data gen security group. And just be a little patient on this, because oftentimes we go to delete the security group and it can't be deleted just yet, because in the background, of course, the instance it's associated with is still hanging around. So we have to wait a few moments for that termination to complete, and then we can clean up the security group as well. By the way, probably a really fun idea just to jump into S3 and get a visual on that data that we hope is there. So when I go into S3, there I can see the bucket, the A Sequera 2 Redshift bucket, and look at that, there are the tables of those various sizes. That looks great. So data generation, yep, it can be a breeze thanks to great tools that are available to us and a nice workhorse VM inside of EC2. I suppose there's lots of cases like this inside of AWS, but I really must say it is a great example of just how incredible a managed service can be when you see how simple it is to deploy something as sophisticated as AWS Redshift. Before we deploy Redshift, though, let's just take care of a couple of prerequisites. The first one is identity and access management. We're going to want our Redshift deployment to be able to access the S3 service, where we know we'll often have resources there that we want to bring in to the Redshift environment, right? So we want Redshift to pull in data that we have just dumped into an S3 bucket. And we know that we are going to use roles in order to give access from one service to another from a permissions perspective. So let's get in here and let's create a role for that purpose. Notice that it will be a role based on Redshift, and we want it to be customizable. So we'll go to the next step here of permissions, and it's going to show us a whole bunch of potential permission sets. And what we're interested in is S3. And think about it, the Redshift service would really need read-only access, right? That's it. Yeah, if we're going to be dumping data into S3 that the Redshift service is going to consume, it just needs that read-only access. So we'll go to tags next here, and it's always, a great idea to, at the very least, have a name tag. We'll call this the role underscore Redshift, and we'll next review what we have created here. We'll give the role a name of role underscore Redshift, and we could add a description. We can confirm the permission set that we need, and we'll create the role. Something else that we should do from a prerequisite standpoint is let's go ahead to the EC2 service, because that's going to give us access to the security groups. There's probably another way to get there, but that's the simple method that I use. And we're going to create a new security group. This will be SG underscore Redshift, and I won't put in a description. It's in our default VPC. That's great. And we are going to add a outbound rule to the security group. No, actually, we're going to add an inbound rule, because we know the outbound rules permit everything, and that's just fine. We need an inbound rule, though. And our inbound rule, of course, needs to accommodate the Redshift traffic, right? The traffic that's going to be coming inbound wanting to access Redshift. And we know that we'll use the default Redshift port of 5439. So if you look inside here, I think they'll even have Redshift. Yeah, look at that. They even have it in here, so we don't have to memorize that port number. And when it comes to what's going to be permitted as far as source addressing, we're going to cheat here, and we're going to use the entire internet we know in actual practice we would be much more careful. And notice this security group does require a description, so I'll just say security group for Redshift testing, and we are going to go and create that security group. All right, with those prerequisites out of the way, it's now time to deploy Redshift. So I'm going to do a search on Redshift, and we're going to go to that managed service of AWS, and we are going to choose Create Cluster. Notice there is a cluster identifier, and I'll go ahead and stick with that. And I love this. They now have this interface where you can say, look, we're setting something up for production, or we're setting something up and we want a free tier, a free trial of the services. So that's pretty cool, and it'll break down the costs that are associated, because let's face it, this is so sophisticated, nothing is ever completely free, right? But anyways, we're going to pretend that we are doing our production deployment here, or at least we're going to test a production style deployment. Notice there are the RA3 and DC2 image types, so we can get like pricing information right away here. Notice we've got this one at 25 cents per node per hour. That's great. We'll do just the single node, and it gives you a little configuration summary, talks about what you'd be spending per month. But of course, the way we are going to be spinning up clusters and then pulling them down right away, destroying them, we don't really have to be worried too much about costs. Now, there's the database configuration section, and this is obviously critically important. So we have a database name of dev, we have the database port of 5439, and the master username and master user password must be provided. So I'll just go ahead and say this is going to be admin, and for a password, I will just make one up here, and I got to make sure it meets the requirements. So let's see, the master password can only contain, I've got a character in there that it can't contain, so there we go. We'll set it like that. And there's cluster permissions, and this is exactly what we want to select for that role that we created earlier. There's our role underscore Redshift, and we want that associated. We'll be covering many of the options that you could do as far as additional configurations later on, but for now, we're ready to say create cluster. And again, that was so incredibly easy, wasn't it? I mean, remarkably simple, and that remarkable simple approach there is really creating something quite sophisticated for us, a cloud-based data warehouse. It really, really is amazing when you think about it. Now, of course, we're going to talk saving money when it comes to Redshift. That's a big part of our examination of best practices. But from a lab perspective, now that you can see our cluster is up and available here, from a lab perspective, I wanted to talk to you about a couple of things quickly here. Number one, yes, we could save the most money when we're done in our lab by selecting the lab and going up to the Actions menu and choosing Delete. So deleting the cluster is certainly a great way to save all of that money, potentially, right? But there is another option that I wanted to cover here with you, and that's pause. So notice we can pause the cluster. And when you do this, it's going to trigger a snapshot creation, by the way, but it's going to pause the cluster, and it's not going to be charging you the on-demand charges associated with your cluster nodes. So that is great. That's a big cost savings. Now, keep in mind, notice how this DC2 large instance is 160 gig disk. We are still going to be paying for the disk space. So that is something to keep in mind. but obviously that is pennies on the dollar compared to running the cluster. So it's very interesting with this service. We have another cost-saving opportunity here beyond getting rid of the cluster. So I wanted to make sure to point that out to you early on. Many of you will be doing some lab practice, and you're not going to want to delete the cluster. You'll want to just pause it because you're going to be coming back in a few hours to resume whatever you were working on. One more comment too right now, just because I happen to see it and it's something worth mentioning. We know we created the security group, which would be controlling access to the cluster for running our queries and experimenting with our data, and that's great. The security group is the component, the firewall component that you want to be aware of. But just realize that you have a query editor built right in. So the query editor will allow you to go in and run queries against your cluster. Ours is paused, so of course it's wondering what we're going to run it against, and it's offering for us to create a cluster. But when your cluster is up and available, of course, you can use this built-in query editor, and you are circumventing the firewall that we configured, which is the security group. So just keep that in mind as well. So we have our Redshift cluster ready to go. Let's see if we can connect to it. And to connect to the Redshift cluster, we will use an often used tool, and that is the SQL Workbench. Specifically, we're going to do the SQL Workbench J, and this is easily downloaded. Of course, this is a free tool. And so you can see my executable here, SQL Workbench. I'm going to run that as the administrator, and we will see that we are asked to select a connection profile in this tool. All right, great. So we're going to be utilizing the Amazon Redshift JDBC driver is what we want to use. The username is admin, as we remember when we were setting up the username and password for the database itself inside of Redshift. And I'm going to put in the password that I specified there. And once you have these parameters filled out, you can say test. And if you have a JDBC driver issue, well, then you've got to make sure you've got that driver ready to go. And I do believe I do have that. Let's see, in this folder, we can see that I have the appropriate JDBC right here, driver for Redshift utilization. So what we need to do inside the connection profile here is go to Manage Drivers. And for the Amazon Redshift, we need to tell it where that driver is located. So it's gone into my downloads folder, and it has found this Redshift JDBC, and I'm going to select that appropriate driver and say OK. So now we would have a fighting chance, except notice this URL right here. This is just a sample URL that we would be using to make the JDBC connectivity. We need to get the actual URL. So we are going to head up into Redshift, and we're going to click on our Redshift cluster in the console, and look here, this is our JDBC URL. So I'm going to copy that. That's great. And then we are going to go back over to the connection profile window, and I will paste in the correct URL. So I think we're getting closer. Let's test. Okay, so we've got a lot more done because this time we're getting the connecting to the database. That's good. That's a good sign. But I can already tell you it's taking too long, right? So this should be a quick connection, and clearly something is wrong. And you will see that we get an error message. Error setting closing connection, connection timed out. So notice that this is kind of a classic we can't connect message. And there are two things that we're going to look at to rectify this. One we should kind of be aware of. The other is something that you may not have realized about Redshift. So the first thing that is a challenge for us with connectivity always with AWS services is the security group. And you remember we created a security group for our Redshift cluster that permitted Redshift traffic inbound on the default Redshift port, but we didn't assign that when we quickly used the wizard to create our cluster. So no problem. I want to show you how easy it is to edit parameters like that in your cluster. So remember, there's our cluster identifier, there's our database name that we set. But if we come under network and security, here's the problem right here. When we didn't set the security group, it went and just applied the default security group. And the default security group is not going to be permitting Redshift access. So there we go. We have the correct security group assigned. So I'm going to choose modify cluster, and we have modified the security group assignment. By the way, you might have noticed that little we can't do anything right now because there's current changes in progress. That was a stale message from something I was doing earlier. So no problem. That's how easy we're going to be able to go in and modify those cluster parameters that we had initially done during setup. But there is one more thing we need to take care of here, and that is very unique to Redshift. Let's take a look. If we go under the Actions menu, notice that right here we have the ability to modify the publicly accessible setting. So if I click on this, we discover that, oh, this is good, that it is permitted. So this will default to no public accessibility. Now, I was playing with this earlier, so that's why it wasn't at the default. I apologize for that. But yeah, all you need to do is come in here and change it from the default of no and say yes, that you are going to be accessing the cluster from outside of your VPC tool. So excellent. And notice you could even assign an elastic IP from here, but we won't bother to do that. So two key parameters that you would be needing to check. Is your security group correct? Is your security group associated to your cluster? And is public accessibility permitted? Well, now that we have checked those things, I think I'm ready to go back into the connection profile tool and let's try the test again, and look at that, it's successful. So why we were not successful a moment ago, it came down to one thing. Public accessibility was already turned on, but what was not turned on was the correct security group. So that is great. Now, I'm sure you don't want me to end this demonstration here, right? Of course not. We want to actually do something, right? So let's go ahead and bring it into view. And that is, of course, our SQL Workbench J tool. And let's actually run something, right? So let's actually see this tool in action so that we can be 100% confident that we've done all this right. So let me grab a little sample SQL code. Let's go ahead and create a table named persons with those following fields and parameters. So we're going to run this against Redshift, and you can see in just 0.12 seconds, we created the persons table. So it works great. By the way, I suppose we will be good citizens here. And of course, we're going to drop the table. So let's go ahead and get rid of that table. And you can see that occurred in even less time. So that is excellent. We've ensured accessibility to the important Redshift service and our database inside it, thanks to, in this case, the JDBC tool, but you're going to find a similar workflow for the various tools out there that you might want to be using in conjunction with AWS Redshift. Down here, notice I've still got my SQL code, that powerful copy command. So we're going to run that, and we are hoping that we successfully copy that data in with the copy command. And again, the amount of data here, I'm really hoping we see some fantastic performance. And in fact, it'll be so quick, I'm thinking, if everything is working properly, that we won't have to pause the video even. I'm guessing, I'm thinking this will take around 45 seconds. And right when I said that, it finished, and the elapsed time of that copy was 35 seconds. So you can start to do some math, right? We had a half a gig worth of data, and we got it in 35 seconds. When you're talking about massive quantities of data, well, things get more complex, and we'll be discussing best practices around that coming up in the appropriate data migration module. All right, now, you never, ever, I don't know about you, I just, the older I get in information technology, the more it is ingrained in me to double check everything that you think may have occurred. So we don't have to go anywhere here. We don't have to we don't have to leave this handy interface, and we can go right up here and we can take a look at the public schema, and there is the line item table. And if we click the little three dots here and say preview the data, well, look at this, we're going to get proof that we have all that valuable carved rock fitness test data inside of Redshift. It's great how we can do all of the verification right in the tool that initiated the copy. Now, from a cluster management perspective, we have a few items to discuss here. First of all, you do have the ability to resize your cluster. So this is simple. We'll select the cluster, and then we'll go up to the Actions menu, and notice under Manage Cluster, there is the Resize option. If you are at a single node cluster, or you want to move to a single node cluster, all you're going to have the option to do is a classic resize, unfortunately. And the unfortunate part about that is while you are changing the number of nodes or the node type or both, the cluster is going to be read-only for anywhere from 2 hours to 2 days, depending on the overall size of your data warehouse. If you are at a multiple node cluster, you set this up through your production environment, you can do an elastic resize, and you're going to be read-only for like 10 to 15 minutes. So keep that in mind. And what's great about this is as you input a new cluster configuration, you can get information about what it's going to cost you right here. If I went to the RA3 16X large, for example, and I decided I was going to go up to 2 nodes, and I had 128 terabytes of total storage, I would know that I'm talking about $26 an hour to utilize this type of a resize. Notice you can resize now, schedule it for a later time, or schedule recurring resize events. So lots of great options for us there. Something else to consider is the settings of the Redshift itself. And this is done like it is in many of the other database technologies of AWS and databases in general. It's done with a parameter group. So in order to see the parameter group, you can, well, one really easy way to see it is to click on the cluster itself. And then if you go to Properties, we'll get additional information about this cluster. And right under the database configuration area, we can see the default parameter group is in use. The default parameter group you can click on, of course, and then we can go in and examine the parameters and their values inside of this default group. Now, if you need to come in here and tweak these settings, first of all, you would have a really good reason to do that. You're typically following the AWS documentation when you do this. And second of all, you cannot manipulate this default parameter group. So the approach is you'll create a new one. It will get a copy of these default values. You'll modify those default values as you need, and then you'll attach that new parameter group to the cluster. Something else to consider with the management of our clusters is we are going to have the ability to tell the Redshift that it is not to utilize the internet for the transfer of any of our data inside the data warehouse. So you can constrain all of the routing of the data traffic to the VPC only. By default, it would utilize internet connections, but you can make sure that everything stays within the VPC. This is done with the setting that is enhanced VPC routing. To access that, let's see, there's so many options with Redshift, it can be a little confusing. There we go. So click into the cluster and then choose edit, and we can get into these settings. And if we go into network and security, there it is, the enhanced VPC routing. Notice by default, AWS can utilize both the internet and the VPC for the transfer of cluster traffic. But if we enable this, we'll constrain it to the VPC. That can improve performance, and of course that could have an impact on overall cost. But the bigger concern with doing this, while it seems like, oh, I would always want to do that, just keep in mind that if you've got issues with your VPC, maybe misconfigurations in the VPC, well then sure enough, you're going to have issues with your Redshift implementation. The final one I wanted to show you here, very important, that's in this management of clusters discussion, is the ability to set usage limits. You don't often see this with every AWS service, but since we could get into really, really big costs here in large environments, this is an option with Redshift. So you'll select the cluster, and you'll come under here, and right at the bottom, you have the option to configure usage limits. There are two that you can configure. The concurrency scaling usage limit. This is in those large data warehouses where AWS is dynamically scaling things inside the data warehouse for you so that many, many users can concurrently access it and analyze data. So you can put a usage limit on this, and you're going to be filling out the usage limit, the time period. Notice there's 3 actions that can be taken. The default is logged to a system table. So you're just getting notifications that, wow, you are hitting the threshold you were worried about. You could do alerting, and you could do like an SNS topic so that you could maybe email everyone on the team saying, we've got potential usage problems here. Or if you wanted to go hardcore, you could disable the concurrency scaling feature when it hits a certain threshold. Remember, there's also this Redshift Spectrum usage limit that you can configure. Redshift Spectrum allows you to build that wonderful data lake, specifically data lake house, as they like to say, where we have our Redshift as the central data store and where most of the analysis is going on. And then we have data sources that are located out of Redshift that are being brought in, dynamically incorporated into the analysis. So when we start getting into the data lake technologies, it's Redshift Spectrum that helps us out. And again, we can configure usage limits, and it's going to be those same 3 actions: to log or alert or shut off this service once we hit a certain threshold. These, again, are very valuable parameters we can set in very large environments in order to help control costs. Now, the test environment and testing your various processes, this is going to be hugely important, especially when we deal with solutions as potentially complex as AWS Redshift. So let's remember some best practices around Redshift in this area, and the first is going to be controlling costs. As we've seen already, the costs here can be significant. Now, we have to remember that oftentimes these are substantial savings over us doing data warehousing on-prem, but still, the costs are significant. So we don't want to really take away from the importance and the value of building these great test environments by not being able to afford them. So we really need to be conscientious about costs here, as well as how much time you're investing in, let's say, the deployment of a test architecture. So this is definitely an area where we want to consider tools like automation to really cut down on the amount of time that we are spending. We also want to really try and control the complexity. So we don't want the test environment to be overly complex and to lose the clarity it can bring to us on the testing of certain phases of our operation. So let's break it down into very small, manageable test cases and test operations so that we get the best value from it. And finally, we want to make sure that the data that we are using in our tests is very representative of the actual data that we will be analyzing. And also, we want to make sure that the data is representing the recentness, or as we often call it, the freshness of the data that Carve Rock Fitness is actually going to be utilizing in their production environment. All of these tried and true best practices when it comes to your AWS Redshift pilots and prototypes. Now, sure, we absolutely love to initially learn about Redshift and to experiment with Redshift in that management console, but we know once we're up to speed, the best practice would be to automate the deployment of AWS Redshift, and a really, really easy way to do that is to use, of course, the built-in AWS CloudFormation. Notice that here I am in the AWS CloudFormation, and I'm in the documentation, and we know that they're going to give us resources in here to help us with things like deploying Redshift utilizing CloudFormation. This is the user guide for CloudFormation, and if I do a search inside that user guide here at the documentation page, I do believe they are going to give us, notice, Amazon Redshift template snippets, resource type references, the AWS Redshift cluster AWS CloudFormation template. So take a look at these great resources for the automation of all of this Redshift deployment tasks. If we go to this cluster document, for example, you can see that we are, where are we in the navigation? We're in the Amazon Redshift category, no surprise there, of the massive list of resources and property references inside of the template reference. If we look, there is the template syntax that we would need in JSON or YAML, the two acceptable languages of CloudFormation, and I shouldn't say languages, that's a bit of a stretch, data representation formats. So of YAML and JSON, we got them both, and it's really straightforward once you've gone through our deployment section, And you quickly realize, wow, I'd be filling this all out here and then automating the deployment, and I probably won't forget as many things as I potentially could. And as we did, one of the things I forgot was intentional, one was unintentional to create errors for us, but you get the idea. I mean, automation really does live up to its billing. In actual practice, it does reduce errors, it improves the accuracy of our deployments, it takes valuable overhead time away from us. It's just an excellent practice, and we should definitely consider this powerful cloud formation and the tools that are provided for us for using it. Well, this certainly was an action-packed module. We began by taking a look at the AWS Redshift architecture. We know that there are several aspects of that architecture that are surprising. For example, the single availability zone approach with the clustered system, but we went into great depth on why that is so important. And obviously we reviewed the architectural components too as we were looking at Redshift. We then focused on the deployment of AWS Redshift. This included getting the cluster established. We did some nice troubleshooting of the cluster along the way. We'll have lots more to say about troubleshooting coming up in a future module. And we even took a look at the simple deployment of data to S3 and then the simple import of that data into Redshift. We talked about some key management aspects of the Redshift cluster. This includes key information like resizing and parameter groups and usage limits and interesting options like the enhanced VPC routing option. We also discussed some best practices, 4 big ones that we want to keep in mind when it comes to our test environments. And finally, we emphasized the importance of Redshift deployment automation, and we reminded you of that beautiful AWS CloudShift tool at our disposal that will really ease us into Redshift automation.